increasing and decreasing functions. So we obviously can kind of look at a graph and tell whether a graph is increasing or decreasing. So let's just do this for this particular graph. This graph, where would it be increasing? Destiny, where is the graph increasing? What? It is increasing at both A and D, but what I'm looking for are like ranges. So from like negative infinity to B, or to it is increasing here, but it's increasing this whole section, right, all the way up to here, which is at B. So we would say from negative infinity to B. And where else is this one increasing, Destiny? And assume this minimum point right here is right at 0, even though it's not quite. So where else does this graph increase, Destiny? Okay, this last curve up, right? And so whenever we tell where something's increasing, we're looking where the x values for that section of the graph. So the increasing section starts right here and it goes up. So look at the x value right here is 0. So we would say from 0 to, and then think of x values, not y values. So although this is going up to positive infinity, that's not what we're talking about whenever I give the answer. We're talking about the x values. So it increases for the rest of the time here on that x-axis, right? So it'd be from 0 to infinity. But it's infinity because it means for the rest of the x-axis, not because it's going up right there. Okay. So Liliana, where would this one be decreasing? Very good. So it would decrease from B to 0. Okay. So what I want us to start to connect is increasing and decreasing and what the derivative looks like. So the derivative is the slope of the tangent line. So if I look at the increasing sections from negative infinity, way down here, to B, so right here is where we're increasing. My tangent lines, what do you notice about the slope of all those tangent lines? They're changing. They're also positive, okay? And then over here, even though the graph is down below the x-axis and curved a different way, over here, what do we notice about all those tangent lines? They're still positive, right? We still have a positive slope. So if the derivative of a function is positive, the function is increasing at that point. Because if the slope of the tangent line is positive, it means the graph has to be increasing. And so in between B and 0, right here, the graph is decreasing. If we look at our tangent lines here, what do those tangent lines have in common? They are decreasing, but in particular, if we think of their slopes, what do you know about the slopes of all those lines? They're negative, right? Because you have decreasing lines for all of those, which makes the slope negative for that. So if the derivative of a function is negative, the function is decreasing. At that point. And we have already done this a little bit. For example, whenever we were doing like particle motion, if we had a positive velocity, we knew the particle was moving to the right or increasing its distance. If we knew we had negative velocity, we knew the particle was moving to the left or decreasing its distance there. So we've kind of looked at this a little bit. I know that one of the questions that Harper asked me about on our test corrections was about whether or not the function was increasing or decreasing at that point. So if you look at the derivative, if it is positive, then you're increasing. If it's negative, you're decreasing for that. So whenever we're doing this with just functions, we'll have questions like this. It'll say, find the intervals on which f of x equals 3x squared plus 4x is increasing and decreasing. Okay, and I didn't put this here, but I should have put justify your answer, because these questions, if they're on free response, always say justify your answer. So what we could think about graphing this quadratic, but it's not that easy to graph because it's not in vertex form and it's not going to be the easiest. So instead, what I want us to do is think about the derivative. Okay, so first we will take the derivative, and if we take that derivative, Lakin, what's our derivative of 3x squared plus 4x? 6x plus 4. Okay, and then that derivative, if we want to know where the derivative is positive or negative, then we need to know where it equals 0, because 0 is where it switches from positive to negative, right? We can't get from negative 2 up to positive 5 unless we cross 0 somewhere in between, right? So we'll take our derivative and set it equal to 0, or if it is a fraction, set the top and bottom equal to 0. These are your critical numbers like we talked about yesterday, so it could be where the function's undefined as well. So 6x equals negative 4. So you divide by 6. So x equals negative 2/3. And then I like to make myself a little chart here. So I'll do a number line, and really the only number I need here is negative 2/3 because it's my only critical point. Okay, and what I want to know is whether this derivative is positive or negative, because if I know if it's positive or negative, that tells me something about the function itself. So I'm going to label this f prime of x to remind me that I'm talking about the derivative right now. And so right here at negative 2/3, that derivative equals 0. And so everything below that is going to be the same, and everything above it is going to be the same. So I really only have to pick one number that's below negative 2/3. So what would you guys like to pick? Any number below negative 2/3. Destiny, what number you want to go with? Okay. What? Okay. You could do that, but let's make life easier on ourselves. Let's pick a whole number. So negative 5. Okay. So if I pick negative 5, if I do f prime of negative 5, I get 6 times negative 5 plus 4. And that's negative 30 plus 4. I really don't even care what number it is. It's negative 26, but all I really care about is that negative. It's negative there. And I could have used any number. I could have used negative 1, negative 4, negative 7, negative 1,000. I could have used negative 7 over 3, but it just makes it a little bit tougher to do the problem if you pick something like that. So I know that it's negative here. If I do, then I need any number above negative 2/3. So Wendy, what number do you want to pick above negative 2/3? 5. So we could pick 5. And so 6 times 5 plus 4, that's 34. That is a positive number. Now 5's still easy to do. I usually pick really small numbers that are close. I probably would have picked 0 right there. I probably would have picked negative 1 for the first one, for that. But it doesn't matter, as long as you pick some. I mean, you could use any number that's in that range there. So let's think about what this tells us. This tells us the derivative is negative from negative infinity up to negative 2/3. It tells us the derivative is positive from negative 2/3 to infinity. So let's think about what that tells us about f of x. Okay, if the derivative is negative, what does it tell us about the function? It is decreasing. And if the derivative is positive, then the function is increasing there. So all of these, we always have to write an explanation. And I want you doing this even on your homework, because on the AP exam, there's always some of this on the free response part. And you have to write a sentence explaining it. If you do not get credit. So you can't just say decreasing from negative infinity to negative 2/3. If it doesn't have an explanation, you won't get credit for it. So you would say f of x is decreasing for, I'm just going to use interval notation, negative infinity to negative 2/3. But you could use inequality notation if you want. And we have to say because, and then I usually just say, you can say f prime of x. I usually just do this, is less than 0 for this interval, or just probably f prime of x is less than 0. Or you could say the derivative of f is negative. You can say anything that lets us know that that derivative is negative. Please be very careful here. Do not say it. So if you say f of x is decreasing for negative infinity to negative 2/3 because it is negative, they're not going to give you credit for that, because they don't know if it means the function or the derivative, because the function could be negative yet still increasing. So we have to be talking about the derivative there. And then we would say f of x is increasing for negative 2/3 to positive infinity because f prime of x is greater than 0. Okay, questions? All right, let's do another one. So for example 2, we're supposed to tell where f of x equals x squared minus 9 to the 2/3 is increasing and decreasing. So the first thing we want to do for these is find the derivative. So f prime of x. Justice, how would we take the derivative of this one? Chain rule, yes. Almost all that is right, except we've got to have x squared minus 9 to what power? Negative 1/3. Yes. All right, so all of this, let's try to simplify a little bit here. So we've got, this is in the numerator, so we've got 2 and 2x, so 4x over the 3's in the bottom, and then 1/3 is the cube root of x squared minus 9. Okay, so whenever we do this, the numerator and denominator, we want to set those equal to 0, because if the derivative is 0 or undefined, it's going to give us a critical point that might be a place where we switch from increasing to decreasing. So in the numerator, that's pretty easy. 4x equals 0, so x equals 0. In the denominator, we would have 3 times the cube root of x minus 9, x squared minus 9 equals 0. So here we would divide by 3. It gives us the cube root of x squared minus 9, and that would be 0. We would raise this to the third power to get rid of the cube root, which still just gives us x squared minus 9 equals 0. And then, so that means x squared equals 9. And we'll square root both sides. So x equals, make sure you put a plus or minus 3. It could be positive or negative 3. So our critical points that we have for this graph are negative 3, 0, and positive 3. So on these problems, I usually do a slightly more detailed little graph here. So let's just remember f prime of x was 4x over 3 times the cube root of x squared minus 9. And so I'm going to do a number line and put negative 3, 0, and 3. So I have got 4 different sections that I've got to test. I've got to test everything below negative 3, numbers between negative 1 and 0, numbers between 0 and 3, and the numbers above 3. I could do like I did on the last problem and just plug those numbers into this equation, and if you would rather do that, that's fine. This is what I do a little bit differently. So I make myself a chart, and on this chart, I do this. Let's see, let's start from the top. So I take each piece of the graph. So the first piece I'm going to take is, let's see, the first piece I'm going to take is the 4x. And so over here I've got 4x. And 4x, if I think of plugging in a number below negative 3, that's negative 4, that'll be negative. And then a number between negative 3 and 0, it still gives me a negative number. And then from 0 to 3, like if I plug in 1, that gives me a positive. Plug in a number bigger than 3, that gives me a positive. The reason I do it this way is because it's a lot easier to plug those numbers in your head than plugging in all of it. In the bottom part, I have a 3, and then I also have a cube root of x squared minus 9. So for my 3 is just always positive. Now technically you could leave that off. You don't have to put that for this. However, if it was a negative 3, you've got to put it there because it changes the sign if it's negative 3. But I'm just going to write it there just out of habit. Every piece needs to be there. And then we've got the cube root of x squared minus 9. And so if I'm picking numbers to plug in here, I've got like a number below negative 3 might be negative 4. If I had negative 4 squared minus 9, that's 16 minus 9. I was drawing circles on my, okay, so negative 16 minus 9 is 7. The cube root of 7 is a positive number, so I'd have a positive here. If I pick a number like negative 2, and I'd usually do this in my head, negative 2 squared minus 9 would be 4, minus 9 would be negative 5. If this was a square root, that would be a problem. It would be undefined for that section, but you can take a cube root of a negative number. So this is going to be negative. If that was a positive 2, it wouldn't change anything. You'd still get a negative here. And if this was a positive 4, it wouldn't change anything. You'd still get a positive here. Okay. Now this is why I do it that way. I think it's really quick just to plug those numbers in really quickly in my head. And then if we think about what we would have in this section, I would have a negative, let's just think about just right here. 4x is negative, so it's on top. Then I've got a positive number, which is my 3, and then times another positive number. So if I have a negative over a positive times a positive, I'm going to get for f prime of x, I'm going to get a negative number. Because all you care about are positives and negatives. You really don't care about whether or not it's negative 72 or whether it's negative 4. So you would get a negative derivative from negative infinity to negative 3. Well, if you look at the next part, you would have a negative number over a positive times a negative, which would be negative over negative, which is positive. Now, to shortcut this, I will tell you that if you have an even number of negatives, then you're going to get a positive, because negative times negative gives you a positive. If you have an odd number of negatives, you'll get a negative here. So like if I look right here, I only see one negative. That tells me I'm going to get a negative in that part. Here, of course, they're all positive, so they'll be positive. Okay, you don't necessarily have to do it that way. You could have just done f prime of negative 4, plugged in negative 4 for, I don't know why it's in the circles, 4 times negative 4 over 3 times the cube root of negative 4 squared minus 9. The only thing is I think that takes a while to do. And I have done this a lot where I think the chart is a little bit easier. But what we're really concerned with is that derivative and what sign it has. So I kind of ran out of room here. I'm going to do my f of x below. So my f of x, this tells me since my derivative is negative, f of x is decreasing, positive, increasing, negative, decreasing, positive, increasing. There. It doesn't always alternate like that, but it does alternate a lot. That happens. It's pretty typical that you see an alternating pattern. If you ever have to guess whether it's positive or negative, go with the alternating, but sometimes it does not. Okay, so to answer our question, we would say f of x is decreasing for negative infinity to negative 3 and from 0 to 3 because f prime of x is less than 0, and we could also say f of x is increasing for negative 3 to 0 and 3 to infinity because f prime of x is positive. Sorry about all the circles that keep popping up for no apparent reason. Okay, questions? Okay, let's do another one. Okay, so this one is calculator active. So if we get our, it says let f be the function with the derivative given by f prime of x equals sine x plus x cosine x for 0 to pi. On which of the following intervals is f increasing? Okay, now if we had the graph of f, we could just look at the graph of f and tell where it's increasing, right? But did they give us f? Can we find f? No. I know how to find f because I know something you don't know called integration. But you guys definitely don't know how to find f. Actually, you'd have to have initial conditions so even I don't really know how to find f. So we can't find f, but they've given us the derivative. So if we look at the derivative, we can find the characteristics of the derivative, and that can tell us something about f. Okay? So keep in mind, we're going to graph f prime of x on our calculator. So everybody follow along, get your calculator out. Everybody got them today. Justice, you probably do not, since you did not come in with any baggage. You know where yours is at, right? Okay. All right. So let's go to y equals. Let's type in this equation. So sine of x plus x cosine of x. All right. And I want to graph this, but notice I'm only looking from 0 to pi. So it's in your best interest, go ahead and restrict that window from 0 to pi before you even begin, so that you're not looking at a lot of unnecessary graphs. So to get to the window on this calculator, you're going to do the green button and F2. And I'm just going to tell it from 0 to pi. And then I'm going to hit graph. Uh-oh. Why did it do that? Oh, sometimes it doesn't like it if you put the X right next to something. Maybe that was wrong. All right, let's see if it'll graph it now. Okay, does everybody get theirs to graph? If yours gave you an error like mine just did, sometimes it doesn't like it when you just do x cosine x and no multiplication sign in between it. But then sometimes it will work, so I don't really know when it does and doesn't work. I haven't figured that out. But, all right, so keep in mind here, we are not looking at f of x, and they're asking us about where f of x is increasing. Not this graph, but f of x. So, if f is increasing, what do we know about the derivative? The derivative is positive. So we're looking not for increasing or decreasing here, but where the derivative is positive. So if I look at the graph, that graph is positive, looks like from 0 over to, looks like it's about 2. In fact, since this is multiple choice, let's just look here. I'm pretty sure the answer is B, right? And if I am rushing through and about out of time, I would just pick B and go with it. Let's do F5 and find that 0 right there just to be sure. Lower bound. Upper bound. Yes, 2.0287. So that's 2.029. So for this one, we would choose B. And if this is free response, we would say that f is increasing on that function because f prime is positive on that interval. Okay. One of the most difficult things about this whenever you're looking at the graph is you've got to remember what you're looking at, because a lot of students want to say that it's in, and see, this is what they'll do to you on this one too. I bet you anything that maximum is at 1.077. If you do find the maximum point, goodness gracious, this is slow. If you do find that maximum point, it is going to be at 1.077. So students that answer A are thinking, oh, it's increasing from 0 to 1.177. That is talking about that function, not f of x. This is the derivative you're looking at. So you're looking for positive or negative for it. Okay, questions? All right, here's another one. This one is not calculator active. It looks like it should be because it's kind of cruel, but it's not calculator active. So we want to know where this function is increasing. So if f is increasing, what do we know about its derivative? It's positive. Okay? So we first have to find the derivative. Oh, we've got a lot of stuff here. This right here, I've got this stuff times this stuff. So what do I have to use to multiply that, or to take the derivative? Product rule. And within that product rule, we'll have a little bit of a chain rule there. So using the product rule, Liliana, how would we take the derivative of this? Oh, there's the stupid circles again. Possibly. Depends on what you're going to tell me it's multiplied by. Okay, so we'll have, so you're doing derivative of the red times the blue. All right, so we'd have 2x times e to the negative 2x. So that is the derivative of the red times the blue. Then we have to do plus, yes, almost. It is going to be e to the negative 2x, but because you've got something in that exponent besides, you'll have the negative 2 out front, right? Because you got to take that derivative of the negative 2x. So our derivative of the blue is that, and then what do we multiply it by? Very good. Oh, it is 2x plus 1. You're right. I was treating that like a constant. Liliana tricked me into thinking she was right there. I had too much confidence in her. See, I'll blame that on you, don't you? Okay. So notice both of these have that e to the negative 2x. So I'm going to pull that out front, e to the negative 2x out front. And then I would be left with 1 plus 2x. And then I've got that negative 2, and then this x plus x squared. So I'm going to just put negative 2 times x plus x squared. So if I distribute that negative 2, I've got e to the negative 2x. Circles are going to drive me crazy. And the positive 2x and negative 2x cancel each other out there. So my derivative is e to the negative 2x times 1 minus 2x squared. Thank you, Alex. Okay, so for this one, you guys set this equal to 0, and since it's already kind of factored, each one of these two parts are set equal to 0. E to the negative 2x equals 0, and 1 minus 2x squared equals 0. And so I'll start over to the right hand side because that's easier to do. 1 will equal 2x. 2x squared, and then divide by 2. So and then I'll square root both sides. So I get x is plus or minus the square root of 1 over 2. But notice that you don't see that number over here anywhere. They rationalized it because that's 1 over the square root of 2, which if you multiply by square root of 2 over square root of 2 gives you x equals plus or minus square root of 2 over 2. If it is free response, do not rationalize. You might mess up and cause a problem for that, so don't do that. But on this one, since it's multiple choice, we can see that they've rationalized that, so we need to make sure those are the same. All right, how do I get rid of an e? Natural log. So if I take natural log of both sides, I get negative 2x equals, what's the natural log of 0? You got your calculator out, type it in, natural log of 0. Undefined, okay? So if you obviously can't solve any further than that, you don't get any answers for this. E to any power is always positive. Because what you've really got here is 1 over e to the 2x. And e to any power is always positive. So even if you have a negative number here, you're still not going to get a negative answer. All right? E to any value is always positive. So any e to anything is never going to give you a 0. It's always going to be positive. So we just have the square root of 2 over 2, or negative square root of 2 over 2, and positive square root of 2 over 2. And so if I'm doing this problem, I've got two parts of this graph. I've got this e to the negative 2x, and I've got this 1 minus 2x squared. So really, when I'm thinking about this, e to the negative 2x, it is always positive. So I don't really have to consider it very much. 1 minus 2x squared, that's really what's going to tell me whether or not this is positive or negative. So a number lower than negative square root of 2 over 2. Negative square root of 2 is going to be like 1 point something over 2. So this is less than 1 because 2 is bigger than square root of 2. So we could use negative 1. So 1 minus 2 times negative 1 squared is going to be 1 minus 2. We'll get a negative number here. If we pick something in between here, what's the easiest number to use here? Between negative square root of 2 over 2 and positive square root of 2 over 2? 0. We plug in 0. 1 minus 2 times 0 is 1, so that is a positive number. And then if you plug in positive 1, it's going to be the same as if you plugged in negative 1 because you're squaring it, so you get a negative number there as well. Okay, and so f prime of x really is just the same as that second line because this is positive, so we get this. So f of x would be decreasing, and then increasing, and then decreasing. And this problem, what did it ask us for? Increasing or decreasing? Increasing, and increasing is just right here between negative square root of 2 over 2 and positive square root of 2 over 2. All right, questions? We don't have time to do the next couple. Let me just look real quick at 5. We're not going to write everything out, but this is the graph of the derivative. So if we want to know where f is decreasing, what are we looking for on this graph? Negative. So and not negative slope, but just negative below the x-axis. Okay, so the parts of this graph that are negative would be right here and right here, which if we're given the x values, this would be from negative infinity up to 3 here, and from 1 to 5. And so I'm not going to write out the whole thing because there's no time for that. But you would say that the f of x is decreasing on these intervals because f prime of x is less than 0. Okay? So your homework for tonight, you should be able to do all of it. You're on page 233. You're really doing 1 through 20. 1 through 8, just look at the graph. It says like to verify using algebraic methods. Don't do that. Just look at the graph. 9 through 20, you're doing by hand. Let me look real quick. Sorry, guys. Late. Let me look real quick and see if there's some I want you to do with a calculator. Just cross my mind now. The last 4 you can use